So till now we were learning that how to formulate an hypothesis, that this is going to be my null hypothesis or this is going to be my alternate hypothesis. Now in this portion we are going to discuss that how to make a decision whether this hypothesis is going to be I should accept this hypothesis or should I reject this hypothesis. How to make that decision. Now in order to do that there are various methods. So I'm going to start with first method called as critical method. Let me start with an example. Let's say I play a cricket match and I tell it to you that my average score in cricket match is 70 runs. Okay, means every match I play on average I score 70 runs. Now, what you did to test it, you said that okay, fine, you are claiming this, but can you play 5 matches in front of me and then I will make some inference about you. So in that case, let's say I played 4 matches, and I got basically my average score as 20. Now 20 is my average score what I got. So what you will say about my claim? So will you say that yeah, this guy is saying truth, or would you say that this guy is falsely claiming it? Most likely will say that it's less likely that you're saying the right thing, because if you're claiming that 70 is a score but 20 is your answer, then looks like you are pretty far from your claim, right? This is in a normal way we kind of say that. Similarly, if I scored, let's say not 20 but 65 as my average mark, then 65 as my average runs. Now what you would say? Now you might say that yeah, maybe he's telling the truth, he's around the number what he is claiming earlier, so I can somehow relate to this number. So this is how you kind of generally make your decisions as a normal human, right? Now we will see that how to formulate it in terms of your hypothesis term. So if we go ahead and see this, so we will be plotting this, let's say, into a graph. So I'm plotting this, let's say, with my new S70 because that's what my claim is. And if you notice what I've done, I am basically putting my numbers here. And what I'm going to do here, I'm going to point a number which is going to be called as LCV, which is called as lower critical value. And I'm going to come to a UCV, which is going to be called as upper critical value. What's the significance of it? My significance of it would be that if my number which I'm getting, let's say 50 is the score which let's say I have created. So definitely my null hypothesis is going to be that my average is 70. We go with the innocent claim. Now here, if this X as 50 which I got is going to fall basically near to this new, but basically before this LCV, then I would say that okay, your claim is correct. Okay, means you are scoring 70 marks. But if somehow this X as 50 is going to fall here, okay, this part means below this LCV, or maybe here, maybe you scored like 150 runs, right? So maybe then also your claim is wrong. Your average is higher than 70, correct? So it depends on where this number is going to fall, and we're gonna learn this, that how to calculate this LCV or UCV. Okay, right now we're just trying to understand from the business perspective that how to decide this. So right now we are deciding this, that if my number, this whatever we got, my average score or whatever we got is basically before this LCV is kind of going to be less than LCV, right? Or greater than UCV, we are going to say that we are going to reject our null hypothesis, because then we cannot say that okay, nu is equal to 70 in this case. And if your value is going to be less than UCV, means less than UCV, but greater than LCV, means within this range, then I would say that I'm going to accept my, means I can't say accept my null hypothesis, I should say fail to reject my null hypothesis. Okay, this is what we have learned as well. So now this is the way we will be making this call. Now definitely you can make out that it will be a very important factor for us to determine how to get this LCV and UCV, right? Because this is how we will be rejecting or fail to reject my null hypothesis. So we will see to that how to do this. But before that, one more thing. There are two kind of hypothesis with us. One is your directional critical region part, and second is your non-directional. So the example which you were just seeing, where I said that I scored 70 runs in per match, which is basically going to be a two-tail test. Okay, what does this mean? If you look at this part, there were two regions, one is LCV and one is UCV, where I have a rejection zone. Either you go above or you come below. So basically this is going to decide my two sides of basically rejection zones. That's the reason we will be calling this particular portion as my non-directional, and it's called as two-tailed, because at both the tails we will have our rejection being available. This is also one way to look at. If your alternate hypothesis have not equal to symbol, that means it's going to be a two-way, as you can make out from this example as well. Okay, so this is also a one way to check your two-tailed test. Similarly, there is one-tailed test as well, which is either going to be a left-tailed test or a right-tailed test. This is called as directional test. Let me show you some examples. But before I go to that example, let me also tell you one live example where this two directional test will make sense. One is, I just explained you about my score, cricket score, what I can get. Second could be, it may be quite applicable, let's say for medicines. Let's say there is a company which is generating this paracetamol tablet, and let's say they know that the optimal quantity of paracetamol should be 500 mg. Now it's very important when you will put your hypothesis testing that it should not be below a lower critical value or the above, because if it is below a lower critical value, if it is too less value than 500 mg, then in that case maybe that medicine will have no impact on the patient. And if it is too high, then it's going to have a side effect. Means if I go to the upper critical region part, maybe that medicine will start showing a side effect, right? So that's where this example will float in. Now, when we talk about lower-tailed hypothesis or a right-tailed hypothesis, what we basically do, we can also call it as left-tailed or lower. Even right-tailed will be also called as upper-tailed sometimes. So if you have a less than symbol in your alternate hypothesis, just like how we have not equal to symbol for alternate hypothesis in two-tailed, similarly if you have a less than symbol in your alternate hypothesis, then it's going to be a lower one. Means on the left hand side you will have a critical region, but on the right hand side you will not have any critical region. Similarly, if you have a greater symbol for your alternate hypothesis, then it's going to be a right-tailed or a upper-tailed test, where your basically rejection region is going to be on the right side but not on the left side. To give you an example, remember that Nestle Maggie example where we want that 2.5 ppm, right? So that can be one example of one-tailed test where I'm not bothered about the rest of the values, but on the left side or the right side. So that's basically is an example of one-tailed test. Now we will further formulate and see how practically we can solve it. So I will take a practical example so that you get a better idea that how we calculate that UCV, LCV, and how to decide which hypothesis to reject and which to basically which we fail to kind of accept. Okay, so we will see that into the next video lecture.